Hey everyone! Today we're diving into one of the most important shapes in geometry, the triangle. Now, I know you've all seen triangles before in road signs, bridges, and even pizza slices. But have you ever wondered why we care about the different kinds of triangles? By the end of this lesson, you'll understand not just how we classify triangles, but also why it matters both in math and in the real world. Triangles are everywhere. Let's start with how we describe triangles by their sides. A triangle always has three sides, but those sides can be the same length or different lengths. There are three main types. Equilateral triangle. All three sides are the same length. Think of a yield sign or a perfectly cut piece of pizza. Each side is equal. Isosceles triangle. Two sides are equal. You might see this shape in roof trusses or on bridges where two sides match for balance. Scalene triangle. All sides are different. These show up in irregular structures like mountain slopes or ramps where no two sides match. We classify by sides to understand a triangle's symmetry and strength. Equal sides often mean equal angles, which helps when designing things that need balance. Now let's switch gears to angles. Every triangle's angles add up to 180 degrees, but the type of angles it has makes a big difference. Acute triangle. All angles are less than 90 degrees, pointy and compact, like in some modern building designs. Right triangle has one angle that's exactly 90 degrees. Super useful in construction, carpentry, and even computer graphics. Obtuse triangle. One angle is greater than 90 degrees. You'll see these in art, design, and roof shapes where you need a wider angle. We classify by angles to help describe how the triangle sits in space, sharp and narrow, or wide and open. Why does it matter? So why spend time learning to classify triangles at all? Because triangles are the building blocks of almost everything around us. Engineers use right and equilateral triangles to design bridges and towers. They're stable and distribute weight evenly. Architects use obtuse and acute triangles to create unique roof lines and artistic structures. Game designers and animators use triangles to build 3D computer models. Every character or mountain in a video game is made up of thousands of tiny triangles. Understanding how to classify triangles helps us talk about shapes precisely, predict how they'll behave, and use them creatively. So, to sum it up, we classify triangles by sides: equilateral, isosceles, scalene. We classify by angles: acute, right, obtuse. And we use this knowledge to understand structure, design, and balance in the world around us. Here are some examples of triangles in the real world. Here's an assignment to complete to show your understanding of classifying triangles by sides and angles.